Hello, my name is Kasper and I work as an Android developer for Storytel. I would like to talk about memory leaks on Android. So a memory leak happens when you have an object that is supposed to be garbage collected, but there's something that is holding a reference to that object and therefore prevents it from being garbage collected. And then it will actually stay in memory. And in some cases, if you keep on getting those memory leaks, you will eventually get a out of memory exception. And so these things we would of course like to avoid. And I think it's quite easy actually on Android to get a memory leak because like if you go back like 2 or 3 years, we would often see code that you can see here on my screen. This is like something called an async task, and it's inside an activity. And an activity is basically, you can consider it as a screen or a view. And what happens, if you then decide to rotate the device, the phone you have, then it will actually recreate the whole view, so everything will be recreated. But the issue is that if you have a ongoing task, and it has not finished before you actually rotated this device, then it will actually have a reference to this activity that was supposed to be garbage collected, but this task will then keep the activity alive as long as this task is running. So, and I actually have these. This is actually from my job candidate assignment. So this is what the candidates get when they apply a job as an Android developer here at Storytel. And so I usually ask them, because then they are supposed to like rewrite the whole thing here, the whole task, and of course they should do it in Kotlin instead of Java. But they are of course also supposed to fix this memory leak. And when I ask them, okay, why did you remove this async task from the activity? Then most of them will then answer that, yeah, but it's because it could cause a memory leak. Okay, but then I ask them, okay, but what if you have kept this memory leak? What would have happened then? And then most of them actually answers, yeah, but then the app would probably crash. And I'm not very satisfied with that answer because first of all, they say probably, and also they say that the app will crash, and it is actually not correct. Because what will happen here is that the old activity will actually just stay in memory all the time. And when you do the work here, this is happening in another thread, not on the main thread. But when it finishes, it will come to this. This is like a callback where it actually will post the result on the main thread. And they will many of them will say, yeah, but here it will crash because this is null, this is destroyed. And but that's not true, because if it was destroyed, if it was null, then we wouldn't have a memory leak because it would have been garbage collected then. So of course it's not null here. It's actually it will not crash. It will just be kept on inside the memory. And I would actually like to demonstrate this. So let me try here to have, start the emulator here, and then we have the app. And what you might have noticed is that I have added this thread sleep. So I'm actually telling it to wait for 20 seconds and then execute whatever that's in the task. And I've done that to demonstrate this memory leak here. So let's try to, we can actually go to the profiler here. We have a memory profiler. Let me see here. I think I need to start it again. Yeah, so here we have it. And we can go into this memory profiler. And let me try to rotate a couple of times here. So what we're doing now is we are recreating the activity, and every time we start an async task, which will then sleep for 20 seconds, which means we have a lot of activities in memory right now. And let's try to make a, what's it called? Let's dump the Java heap here. Then we can actually see what's in the memory. And here we can actually see that we have 9 or 10 instances of the scrolling activity. And actually Android Studio is actually also detecting this for us, so they can actually tell us that here is actually 9 leaks, and you should go and fix that. But as you notice, there was actually no crash, so the app does not crash. It's all these instances are kept in memory. So yeah, that was like my point here. And also I'd like to mention that I think that one of the most common leaks that we have now in Android is when it comes to fragments. In a fragment, there's a lifecycle event called onViewDestroy. And that method is invoked whenever you go from one fragment to another fragment. Then the old fragment is not destroyed if you actually define it to be kept in the backstack. So if it's kept in the backstack, the fragment is not destroyed, but the view is destroyed. And if you keep a reference here to this, for instance, a recycle view, and you don't clear this from memory in the onDestroyedView method, we actually have a memory leak. Because the name of that method kind of implies that the view gets destroyed. But if you keep your reference here, you would then have an old reference, or a reference to some old views that is actually supposed to be removed from memory. Because once you go back to the previous fragment, onCreate view and onView created everything, it will then be invoked and a new view is actually created. And therefore there is no need to keep a reference to this old view here. But yeah, this was just a short demonstration of memory leaks, how you can detect them, and what you should avoid. Yeah, that's all for me. Bye-bye.